the net force on Q3 is a negative X force, negative 7 times 10 to the negative 4 Newton I. I hope you understood the method of doing this problem. Once you know this basic method, we can use it for any other difficult types of problems. Now, in calculating the force between electric charges, we use the absolute value of the charges. That means we will not consider positive or negative signs of the charges. We will calculate the magnitude of the force and then determine the direction depending on whether the force is an attractive force or a repulsive force, like we did here. Let's do another problem. A charge Q1 equal to 5 microcoulomb is on the y-axis. A charge Q1 equal to 5 microcoulomb is on the y-axis at y equal to 3 meter. Now, this is the 5 microcoulomb. And the charge Q2 equal to negative 5 microcoulomb is at y equal to negative 3. This is my charge Q2. Find the force on a charge Q3 equal to 2 microcoulomb located at x equal to 8 meter. There you are. Alright, we will use the same argument like the one we used before. But look at this. We need the distance between charges Q1 and Q3. If you notice, this is the origin. This distance is 3 meter. And this distance is 8 meter. And therefore, this is the hypotenuse of that triangle. R13 squared. What does R13 stands for? Distance of charge Q1 from Q3. R13 squared is 8 squared plus 3 squared equal to 73. So where in the calculation we need the square of this distance, we will use 73. Now similarly, R23 squared also is 73. 8 squared plus 3 squared. Okay, what is R13 squared? 73. R23 squared is 73. And therefore, what is F31? What does F31 stands for? Force on charge 3 by charge 1 will be K Q1 Q3 divided by R13 squared. We know all these. Q1 is 5 microcoulomb, 5 times 10 to the negative 6 of a coulomb. There you are. K times Q1, Q3, Q3 is 2 microcoulomb divided by R13 squared. What is that equal to? 0.0012 Newton. The force on Q3 by Q1 is this quantity. And now you know you need to find the direction. What is the direction of this force? Q1 is a positive charge. Q3 also is a positive charge. Therefore, the force on Q3 by Q1, will it be an attractive force or a repulsive force? They are both positive charges, therefore it will be a repulsive force. The force on Q3 will be directed away from Q1, repulsive force. So this is the repulsive force, and so is directed like this. This is the direction of the force on Q3 by Q1. Alright, let's now find F32. F32, the force on 3 by 2 will be a similar quantity. All these quantities are the same. And that also equal to 0.0012 in which direction? It will be, this is a, now Q2 is a negative charge, if you remember. And Q3 is a positive charge. What is the direction of the force on Q3 by Q2? Q2 will be attracting Q3. Therefore, this force 0.0012 will be an attractive force. This is an attractive force and is so directed towards Q2. Alright, that will be F32. While the force on Q3 by Q1 is a repulsive force, the force on Q3 by Q2 is an attractive force. And now, we have now two force vectors. You need to find the sum of the two force vectors. Now, you know how to find the sum of two vectors. What you need to do is express this vector in the angle, in the component form. How do we represent a vector in the component form? Knowing the angle, well, let me refresh your memory. If you have a vector like this that makes an angle theta with the x-axis, if this is the vector f, then its component form will be f cos theta I plus f sine theta j. That is the x component and the y component. So a vector f that makes an angle theta with the positive x-axis can be written in the component form as f cos theta I, that is the x component, plus f sine theta j, that is the y component. Alright, I suppose you know that very well. Now, we know the magnitude of each of these forces. Now we need to find the angle. Once you know the angle, we can represent them like this. Alright, let's find the angle these vectors make with the x-axis. The net force on Q3 is the resultant of F31 and F32, which means the vector sum of these two forces. To write them in the component form, we need the angle they make with the x-axis. Now look at this. F31 is this angle. Can you see where I'm pointing? That's the angle F31 makes with the x-axis. And F32 makes this angle. That's the third quadrant angle. Let's find those angles. Alright, I have the diagram made bigger now. If theta is the angle F32, let's do this first. This is the angle theta F32 makes with the x-axis. This is the x-axis. That is the angle we are looking for. Well, let's find just this angle. Is that right? Once you know this angle, add 180 to that, you get the whole angle. So, let's find this angle. Can you find this angle? If this angle is theta, then tan theta will be 3 divided by 8. Is that right? Tan theta equal to 3 divided by 8. Therefore, theta is tan inverse of 3 divided by 8. Do it on your calculator. That gives me 20.6 degrees. If this angle is 20.6 degrees, what is the whole angle? That is this whole angle. The angle F31, is 180 plus, you see this is 180 plus 20.6 degrees, that is 200.6 degrees is this angle. So this angle, the force vector F32 makes with the x-axis is 200.6 degrees. Now tell me, we obtained this angle, this acute angle as 20.6 degrees. Can you therefore tell me what this angle will be? That will be negative 20.6 degrees. How do I know that? Well, watch this one here. Let me see if I can show that to you. If I produce this line, there you are, this angle will be theta. Now, if you can see, if you produce that line, this is the x-axis, this angle will be theta, and you can see the symmetry of the diagram tells us that if this is theta, that also will be theta. Now, but this angle is a negative angle because it is the fourth quadrant angle. So the angle this force vector F31 makes with the x-axis is negative 20.6 degrees. I hope you followed my argument. So once again, the angle made by force vector F32 with the x-axis is 200.6 degrees, and the angle the force vector F31 makes with the x-axis is negative 20.6 degrees. Alright, once you have the angle, we know the magnitude of these two forces. Each of them has a magnitude of 0.0012. So let's write each of them in the component form. F31 is 0.0012 cos negative 20.6 degrees I plus 0.0012 sine negative 20.6 degrees J. In other words, it is made up of the x component and y component. And use your calculator to work it out. That gives me 0.0011 Newton I, the x component. That is this, 0.00011 Newton, minus 0.00042 Newton J. That is the y component, this one, 0.00042. You can see the y component, I can either have it here or here. So we wrote F31 in the component form. Let's write F32 in the component form. F32 will be 0.0012 cos 200.6 degrees I plus 0.0012 sine 200.6 degrees J. And use your calculator to work this out. Remember to keep your calculator in degree mode when you do that. That will be negative 0.0011 Newton I. That is the x component. You see this? Minus 0.00042 Newton J. That is the y component. Now if you look at this diagram, look at the x component. There's a positive 0.001 Newton and a negative 0.001 Newton. They cancel each other. So when you want to find the vector sum F31 added to F32, you notice the x components will add to give you 0. One is positive, the other is an equal negative. And the y components are both negative. Look at this. And they will both add, will give you a bigger negative value. Alright, so F net is F31 plus F32, and that will be negative, just add the y values, the x's will cancel. Negative 0.00084 Newton J is the net force on Q3 by both these charges. Okay, I want you to practice this kind of problems. It's a very important type of problems. Another one.